In this video, I'll talk about some of the conventions that are used in naming chemical compounds. Our first one is NaCl. So first we recognize that these letters, of course, represent elements as listed on the periodic table. And Na is sodium and Cl is chlorine. Now this is an ionic compound because we have this metal, Na, mixing with chlorine. And for the ionic compounds, we have the convention of naming it by the cations and the anions. And the sodium ion, Na plus has the single charge, and then the Cl, chlorine, anion, chlorine, is with the one negative charge, and that's chloride. And most of the anions, that is the elements with the negative charge, have the ide, the IDE ending. So this is going to be sodium, and most of the cations, that is the first element listed, usually sounds just like the element name. So sodium chloride is how we're going to name this one. And by the way, that sodium does not need to be capitalized. Okay, the next one, H2O. This is a molecular compound. It's two nonmetals. So we use the convention of either mono or di or tri, and that gives you the number of atoms in the molecule. So mono would be 1, di is 2, tri is 3, and you go on. There's a list: tetra, penta, hexa, hepta, octa, nona, deca, all these prefixes. So I'll say dot dot dot. So what are we going to use for this one? We've got H2O. Well, it's di because it's 2 hydrogens. So dihydrogen, and then we can say monoxide because there's just one oxygen. So dihydrogen monoxide. Harmless. Don't confuse it with carbon monoxide. It's just dihydrogen monoxide. That's water. The next one, Ag2CO3. This is another ionic compound, and we're going to list this by their, we're going to name this by their ions. So you've got silver, Ag plus, and then you have carbonate. So it's actually CO3, and it has a -2 charge. So we're going to need 2 of these, and that's what we have here, is 2 silvers for 1 of these carbonate compounds or ions. So this is really, it would be silly for me to list every single name of all of these cations and anions, but there are lists, and the nice thing and comforting thing for people like me is that there is a structure to this. It's not on someone's opinion of what it should sound like. There's a structure, and so we just follow it. And so you've got silver. You say silver first because that's what Ag stands for. Silver, and again, this does not need to be capitalized, but silver, and then carbonate is this CO3. So we've got carbonate. Silver carbonate. Okay, write the chemical formulas of the following compounds. So this gets a little bit more interesting because you don't see the letters in front of you. But we're told here that this is an acid. So what we're going to do is we're going to go off of some of the reference acids, and there are a few. For this one, it looks like it's the reference the reference chloric acid. And the reference chloric acid just looks like this. It's HClO3. However, that's not the answer for this, because this prefix per, that means to add one oxygen. That's what that means for the acids. So we're going to take this reference acid of chloric acid, and we're going to add one oxygen to it. And so that would give us in the end HClO4. So that's our answer for that perchloric acid. Tin 2 fluoride. This is another ionic compound. And what that looks like is you have the tin ion, and that would be a cation, tin, with a charge of 2. That's what this is telling you. So it's SN is the periodic listing for that, the name, the abbreviation for tin, and it's got a charge of 2 on it, and that's being combined with the fluorine, and the fluorine ion is F minus. That's the anion. So what we need is we need 2 of these fluorine, and this is called fluoride when you're talking about it as an ion, but we need 2 of these fluorine or fluoride ions with just 1 of the tin. So this is going to be SnF2. That's the chemical formula for tin 2 fluoride. Last one, strontium nitride. Beautiful, strontium nitride. That is strontium. Does this 2, by the way, this 2 over here, that's because tin can have a different number of charges on it, whereas some of these other elements just always have the same charge when they are in their ionic state. But strontium, we know, is just going to have Sr2+, so it has a charge of positive 2. The nitride is the name for the nitrogen ion with a -3 charge. So that means that we need 3 strontium elements or ions with 2 nitride ions, and so that'll be Sr3N2. And you can check it out, by the way. Multiply 2 times a -3 is -6, and 3 times +2 is +6, so that the charges should equal out, balance out, so you've got a nice little molecule there. This is actually an ionic compound. Okay, if you found this, I hope you did find this helpful. If you did find it helpful, consider liking it or sharing it with a friend.